covered a little bit aspect of this outline. I have already given the introduction why we have gone for this non-traditional optimization methods. Okay. And the second part is genetic algorithm, because this is the general optimization algorithm. We know that each possible solution either it is evaluated by a deterministic algorithm, whatever we have discussed, deterministic method, fixed method, and the other is the heuristic method or random search method or the stochastic search method. And here I make a category of all these deterministic algorithms, because we have discussed a little bit of this hill climbing method. Hill climbing means this gradient ascent or gradient descent method. There are some branch and bound method, depth first, breadth first, best first, lambda iteration method also. That means you have the initial value of the solution, go on incrementing the value. That is the iterative method. So iteratively go on increasing the value of the solution till you are getting a global solution. So these are the Newton method, gradient method, linear programming, interior point. So these are the deterministic computing methods. Besides that, the heuristic algorithm or the non-traditional optimization algorithm, whatever we have discussed, one is the genetic algorithm, which based upon the survival of the fittest, the evolution process, because initially you have one population, then the population is expanded by means of crossover. You are producing new child, new probable solution, again produce new child. So likewise, you go on developing your problem till you are getting a final solution, or till you are converting to a global optimal solution. Okay. Similarly, the other methods which are available are simulated annealing. Simulated annealing mainly is a chemical process. Okay, your formation of the alloy by controlling the temperature. So that process is evolved to find out the optimal solution. Simulated annealing. Similarly, there are evolutionary programming, particle swarm optimization. We will discuss this thing. Bacteriophoraging, which will be discussed by the speaker tomorrow. Then we have the clonal algorithm. This is basically on the principle of the cloning. You might have heard the recent news dolly. So if you are getting a good solution, try to clone it. Okay, try to copy more number of copy of that. So that is the cloning algorithm. So similarly, there are many methods like artificial immune algorithm. There are also frog leaping algorithm. Many algorithms are there. And remember, all the algorithms are dependent on the biological process. Either we are learning something to optimize from the general evolution process, or we are learning something to optimize from the schooling of the birds. Okay, you see that the simple example you might have heard, the birds from Siberia, they travel in a particular season. They come to India to avoid the cold there, to have get the warmness here. So the distance they cover, a large number of distance. But what is their aim? To reach in India in a specific period of time. Otherwise, what will happen? If they will start from winter there and they will reach in winter here, there is no meaning of traveling so much distance. So they travel with a particular motive, that is optimization. With that particular motive, we learn from that, and we try to model that for our optimization problem. So they start in a group, they start moving from one place, they come to this particular place, okay, during a specific time, in search of either food or in search of shelter or to avoid some dangerous things there. So like this principle is the particle swarm optimization. Similarly, there is another algorithm, ant colony algorithm. You might have heard SEO, ant colony. The ants, they go on searching the food in a specific direction, and they also come back in the same direction after searching the food. So all this biological evolution process, they now gives a new horizon of evolutionary computation, or it is biological inspired computation. Different names are given, and a lot of journals you will find. The main journals which are published in this area is the IEEE transaction on evolutionary computation, having a very good impact factor of 3.5. IEEE transaction, evolutionary computation. Another is evolutionary computation, simply published by MIT Press. Its impact factor is also equal to 2.7. There are also some journals, your applied soft computing, evolutionary computation, swarm intelligence. So a lot of particular journals there where you can publish your research work either in the hardware algorithm or the application. It may be applied to your field, like if you are working in the computer science, it can be applied to the data mining, clustering of the data. If you are working also in the networking, the best application is the sensor placement. Because I am not the master of that, but I have seen some applications of the sensor network placement, where to place your sensors in the particular network, what is the optimal configuration, so that you will get the maximum output. So people are working also in the anomaly detection, people are working in the fault detection. In different area you can also work. Okay, so come to our these things already I have covered theoretically, so I am not. I will give these slides. We have already covered this particular one. Coding, decoding, gear operation. Okay. This is the flow chart. Just very simply, I can tell you. You generate initially population of size 20 or size 50 or size 100 depending upon your application. Choose your chromosome length depending upon your accuracy of the problem. So that is the initial state, generate initial population. Then evaluate your population. Once you are evaluated, you are selecting the best by the gradual selection. Once you are getting the selected candidates or selected population, or best population, then they create new solutions by offspring, generate the offspring by crossover. Then you have the mutation, then you evaluate the offspring, then re-evaluate the original population. So this becomes a cycle. You can terminate if you are getting the last generation, because you mention whether you want to run this program for 100 number of generation, 200 number of generation, 500 generation. So it is a cyclical process. So either you go on keeping this track, okay. So here the record get the best individual of the last generation. Okay. So this is the simple process of the genetic algorithm. These are the simple programs I have. We will go to now this particular. This is another new one. Now what happens? You see, try to relate everything. One your simple optimization technique by traditional hill climbing, gradient method, where you are assuming one solution. In GA, you are assuming a population-based solution. You are going to the next solution by crossover. You make the crossover between the two parents, find out two new offsprings. Okay, that is one. But what happens in this particle swarm optimization? It is a robust stochastic optimization technique based on the movement and intelligence of swarm. What is swarm? Literary meaning of swarm. Is English word? What is swarm? It is a group of birds. It is a group of birds or group of fish. Okay. So those group of birds, they move in a direction, in a particular direction with a certain mode. Or group of fish, you might have seen in the Discovery Channel also. Very beautiful picture of the group of fish, they scoot in a particular direction in the search of food. So that concept, it is a concept of movement from one place to other. Not like in genetic algorithm, you are producing a new set of solution by crossover. It is not like that. You take initial set of solution, then try to move that solution. This is in the gradient asset. You are taking a initial solution x0, try to make one step x0 plus del x. Try to make next step x0 plus del x. So this is a movement, but that movement is guided by a certain principle, increment del x. That increment is fixed. But here it is another movement of the solution, but randomly, again with some motive also. We will see that. So this KSO, it applies the concept of social interaction to problem solving. When we are solving the problem, we have to keep the social interaction among those groups. Let us see how it is happening. These are the two persons, the inventor. One is the Russell Eberhard. Okay, who is the electrical engineer? Basically, he is a faculty in Kansas State University, USA, and the other is the psychologist James Kennedy. They are the inventor, and this PSO optimization technique was invented much after the GA. GA is before 1990, and PSO is invented in 1995 in New Delhi. Okay, particle swarm optimization. Now this question: why do the animals swarm? The animals, they swarm from one point to other. Already I have told you. Either it is a group of fish or it is a group of birds. They swarm either for defense, either in search of food, or in search of better chance to find a great degree of energy consumption. So there are certain motives. These motives are the optimization motives. For that motive, they try to move from one place to other. So now what happens here? See the analogy. Once you remember the analogy, it is not very difficult to remember GA or PSO. In traditional method, one solution, 1 point. In GA, 20 different points. The whole set of the population, whole set of the probable solution in GA is known as population. Similarly, the whole set of solution, initial solution, how they are generated? Randomly. In GA, we are calling population. In particle swarm optimization, we are calling it as a swarm. Swarm means group. So here a group of population. Here the group is known as swarm. In GA, each member of the population is known as chromosome. Here, each member of the population is known as a particle. Okay, same thing. We generate randomly, but nothing else. So that thing. It uses a number of agents or particles that constitute a swarm. So initially you take randomly 20 particles. Those are mathematically 20 probable solutions in the surface known as a swarm. Okay, around the surface looking for the best. The second point, each particle is treated as a point in a n-dimensional space, because simply we have taken initially it is a one dimension fx, but always it is not that your function is having a one variable x. Your function may be having n number of variables. So if it is a two variable, let us x1 and x2. So my surface is a two-dimensional space. It is like this. If it is a 3, it is a three-dimensional space or n-dimensional surface. So there are n dimensions of surface. That indicates that the number of variables present is x1, x2, x3 up to xn. Then each variable is having a range. x1 between this range to this range, x2 between this range to this range, xn between this range to this range. Again there are constraints. It may happen that 5x1 plus 7x2 greater than 0. It may happen that 7x cube minus 5x square plus 3x greater than 0. Whatever. So those are the points. So likewise, each particle is treated. Suppose this is a three-dimensional place, surface. I may have initial particle here. I may have another particle here. I may have another particle there. So every particle now having a coordinate. If it is a three-dimensional surface, it has x coordinate, y coordinate, and z. Or you can tell x1, x2, x3. Like that. So initially you place 20 particles in the whole surface in finding out the best solution. Are you clear this concept? The next point is now see, when you first start, so these are the initial 20 points. So first what you will do, as you are doing in GA, whatever now 20 particles I have placed these 20 particles randomly. For each particle I am generating x coordinate, y coordinate, z coordinate. And these x, y, z coordinate, that means x1, x2, x3 are generated randomly. And the range of x1, x2 and x3 are given, because x1 is having its range between x1 lower, x1 upper, x2 is having its range between x2 lower and x2 upper. Okay, so now suppose you have a problem fx. So here x is a vector, it is not a scalar. Okay, where my x is x1, x2 up to let us xn, n number of variables. Right? Your objective is maximize fx, maximize or minimize, whatever. Maximize or minimize fx. Where x is a vector, I mean n number of variables, x1, x2, x3 up to xn. Every x is a range. Suppose this is x, x1 is having x1 lower limit, x1 upper limit. Similarly, x2 lower limit, x2 upper limit. Likewise, xn lower limit and xn upper limit. Subjected to gx equal to 0. Many constraints are there. Clear? So taking this problem, the initial solution you are generating. Now initially I am discussing the on constraint. We are not going to constraint directly. So this is my suppose first case. My x coordinate is fixed, let it is minus 2 to 5. Y coordinate is fixed, let minus 5 to plus 10. Z coordinate is fixed, let us 0 to 5. So now initially I know the range of x1, x2, x3. So initially I am generating randomly 20 particles having the x1 value, x2 value, x3 value in those range. So I am putting those random. These are the initial position of the 20 particles of the swarm, which are generated randomly. Remember, these are generated randomly. Now, once I will generate this, after GA the same thing, then you are evaluating. Then you have to evaluate this. Now there is no problem because you know your function fx. Then you put this value having coordinate x1, x2, x3. Okay, you evaluate your function, you are getting a function value. Now the problem is how to go to the next step. In GA, how you are getting the next step? The next new solutions, how you are getting in GA? By the crossover operation. Because you are selecting 2 as a parent and making crossover to find the new child. So here in particle swarm optimization I have told you there is no part of crossover. There is only the updation of the position of the particle. Now suppose one particle I have placed in this 3-dimensional place here. Another particle is there, another particle is there. They will move from this place to this place or this place or this place because there are 3 dimensions. So when this particle will move from this particular place to this particular place, so what will happen? There is a change in x coordinate, there is a change in y coordinate as well as there is a change in z coordinate. So it will change its coordinate or position to go from one place to other place. So how it will move? Okay, so that movement is taken. Now you see, get the analogy from the biology. A group of bugs starting from Siberia coming to India. So among those bugs, maybe 75% or 80% of the birds are old. Perhaps in class 4 we have studied a story, the land where there were no old men. The king ordered to kill all the old men. So once the king has ordered, every person may have killed every minute their parents, all the old men. But one fellow, he has just kept his old father hiding somewhere in his ground. Okay. So what happens after 1 year or 2 years? There is a severe drought. So when the severe drought came, everybody is young, nobody knows anything. So they are not getting the food. So that fellow who was hiding his father, he asked, Father, there is a severe drought, nothing is there, nothing is available. So he advised, you go and plow the general way, where generally earlier the carts were going carrying out the grains. You just plow these lands. Why you will plow these lands? There is no grain, nothing else, there is a drought. Fortunately, he plowed these lands. But when the rain comes, so those lands generally on the way, when you transport the grains and some things are there, okay, they give them the food. So the question here is, although it is a very simple story, the point is, you can gain some experience, you can gain some knowledge from the old people. You can gain some knowledge from your fellows who have seen it already. So the question here, when the birds, they start from one particular point in search of food to the another particular point, if all the n number of birds are live, then what will happen? They don't have any experience. But some of them may have some experience. So here in this particle swarm optimizer, it works in the principle of two methods. One is social interaction, another is cognition. Cognition means self. Self interaction, another is social interaction. Social interaction means the interaction among the group. It may not be the whole, but among the group. We decide as a group what to do. We decide as a group where to do. We decide as a group when to do. So that's why this is a very beautiful algorithm, mainly on psychological behavior. Okay. Each particle, remember, see, I will tell you this later on. Each particle keeps the track of its coordinate in the solution space, which are associated with the best solution that has achieved by the particle till now. Now you see, when you are start flying from the very beginning, in the first iteration, so whatever your evaluation in the first iteration, that is the best, because you don't have any previous record. Are you clear, my friend? When I am starting here evaluating these 20 particles, every particle is evaluated and every value of the particle is its own best, because you don't have any record of the previous best. And out of these 20, you are evaluating particle 1, particle 2, particle 3, one is placed here, there, like that. Okay. Every particle has been evaluated. Every value of the particle is its best at present in the first iteration. And out of these 20, one is the larger value if you are making a maximization. So that value is the global best or group best. So you keep the track of two things. Of course, those who are teaching RDBMS or something, they are master in this, tracking of the data records. Okay, so you take the track of two things. One is the P best means particle best till now. But when I am starting, till now means it is the first iteration set. Another is the G best, the global best. So taking these two information, now a particle will move from one place to other. So when it tries to learn from its own individual base, that is cognition. When it tries to learn from the global, that is social interaction. So this in the search space, using particle swarm optimizer, the search proceeds from one point to other by two things, by effect of two things. One is the cognition, one is the social interaction. So till now, only you know mathematically, we have to keep track of P base and G base. Fine. How it happen? Let us see. Suppose I am at kth instant. Kth instant. Okay? So you have already covered how many? That means kth time step. Here each time step is treated as one. Iteration 1, first time, iteration 2, second, iteration 3, third. So now you are at kth instant. So kth instant means the particle has at a position that is denoted by sk, and it has got to its position k with certain velocity vk. Are you clear, my point? So sk is the present position, vk is the present velocity. Now, be clear. If you are allowing the particle to move with the same velocity, now what will happen? It will fly away in that direction. Suppose now, similarly, the number of coordinates you have x1, x2, x3 means you are getting three velocity, because you have to make coordinate updation of x direction, y direction and z direction. So I am discussing only one. Are you clear? So now suppose the particle at present is here, this position. Okay? So, and it has gone to this position with a certain velocity vk, x direction or y direction or z direction. Now it will allow this particle to move with the same direction, with the same velocity, so it will move in that direction. If you want to try to move this particle with a lesser velocity or larger velocity, then you multiply this velocity vk with a weightage w. So if now my sk is w into vk, then what will happen? This is my position of the particle sk. This is the velocity vk. So if I am moving it at the next instant, so at the next instant it should change its position to sk plus 1, isn't it? So if I am allowing this particle to move with a velocity multiplied by omega into vk, so what will happen? In this next position, it may go from this to this sk plus 1. and this may go with a large velocity or with a small velocity, depending upon your choosing of the variable omega. Are you clear? So omega is the acceleration coefficient. You can put a break on that. If omega is very closer to 0, the particle is moving with a lower velocity. If omega is closer to 1, it is moving with a larger velocity. But is there any change in direction? No. So it will go on flying in that direction. So now what will you do? So this is the simple stuff. You move in the same direction, like your breath fast. Like your breath fast, no change in such direction. You just proceed in that direction, either fast or slow. Fine. Now what will do? I will take the experience of my own. So what is my own till now? That is velocity, Vp based. Till now I have already covered how many instants? Kth instants. In iteration 1 I have a P based. In iteration 2 I have evaluated another best. So among these two, whatever best you keep that. Iteration 3 you have another velocity. Iteration 4 you have another velocity. That means till iteration k you have not travelled with a constant velocity. You have gradually updated your velocity. And what is your best velocity till now? That record is Vp best. Similarly, you are keeping the track of the group best. In the group, in first iteration, what is the best velocity? In the second iteration, what is the best velocity? In the third iteration, what is the best velocity? Are you clear? So that is the Vg best. So incorporating all these, incorporating your cognition, Vp best, incorporating the social influence, Vg best. Now you choose your velocity, not Vk, but Vk plus 1 to move into the new position Sk plus 1. So now your movement is governed by not your own velocity, own acceleration, but with that you have another term from your cognition, you have the third term from the social influence. Are you clear? Mathematically, see, each particle tries to modify its position. Position means if you have one variable, only one direction. If you have three variables, you update x1, you update x2, you update x3, so that in three dimensional it will move from one coordinate to other. So they are influenced by the current position where it is at present, that is S. The current velocity, that is your Vk. The distance between current position and paper, Sk and Vp best. Because here position and velocity are mostly same. Because velocity into time. Time is, what is time here? One step. It is one. Okay. So this is the distance between current position and base, and the distance between global position and base. So what will happen now? You see. What happens? If see this equation, only one equation will govern all. The velocity of ith particle, because you have 20 particles, you have to update the position of all the 20 particles. So velocity of ith particle at the instant k plus 1 will be omega into vi at k. Same ith particle up to k instant, what is the velocity? With a omega. So this, it will remove all these things. Vi k plus 1 equal to omega into vi k. So here the particle will move in a fixed direction, either with acceleration or with deceleration. No change in direction. Now you add the second term, C1, some constant, into a random number, random. So C1 random is another random number. One constant into one random number. This is nothing but a random. So that random number into P base I, that means the best velocity of the particle till now, ith particle at now, and where it is at present. So from that, what information you are getting? How much distance you are at present. Okay, till now what is your best velocity, and at present with which velocity you are moving. So how much you have to cover, that information, social information is there. First, so this part is the cognition. The second part, C2 rank 2 into G base minus SIK. So global base minus present base. So what gives it? If the global base, so it now acts like an attractor. The global one means it is the best till now. It will try to attract the other particles Because it is estimating a distance between the present position of particle. Because global is one. In one iteration, one is global. What is the global base till now? And where are you at present? So now you are getting, okay, one member of my group is now far ahead. Okay, he is there. I am here. I am now this much distance from him. So I must have to accelerate my velocity in that direction. And again, you are not taking 100% confidence with that. You have also your own mode. Because if you try to move in that, you may not have that capacity to fly with that velocity. So you are taking your own experience, you are taking your own energy, how much energy I have at present, whether I can fly or not. Again, you are taking some social influence. Being on this all three components, you are updating your velocity to the next slide. Now see, I will show you this in a surface. Okay, so this is my surface. You can see this is the peak of the hill just like this in three-dimensional projection. Okay, this is my global. There are other peaks. You will see to the mountain range. Many peaks are looking, but out of all those peaks, one is global. So here, this is your this one is global. These are some local maximum. So initially, what I am doing? Randomly, I am putting some particles because I don't know the solution. So these are the random particles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Like these are the particles they have. And here, why I have given an arrow? Because here the movement of the particle is governed by the velocity. It has a particular direction because we are updating the x direction, y direction, and z direction, so that the particle will fly in different directions. Are you clear? Now see. Now from this, what is your conclusion? Which particle will be evaluated best? Definitely, this particle will be evaluated best. Why? Because it is very close to the global. Of course, this I don't know, but in my problem, this problem, at least I have the idea. For your understanding, I am telling, when you evaluate all these particles in your function space, you know your effects. The problem is known to you, unless you don't know the problem, how to solve it. You know what is your optimization problem, you know what are your ranges. Okay, now you are assuming these initial solutions. So, the point is, you know that this is the best. So, every particle now when they try to update the position, now the particle which is here, it must orient its direction towards this. Okay, and this will be done by the how far is it accordingly. So, these particles should move with a larger velocity, whereas these particles should move with a lower velocity. Or if it will move with that same velocity as this, it may cross this region. So that's why there is a balance. You are estimating how far you are from the global. Now see how these changes position are changing. See that direction. Okay. This is run by a MATLAB program. We have written a MATLAB program. The program is run, and every time we have stored this position of the particle by this arrow. For your understanding purpose, between the GA and these particles are optimized. Now see another point. In GA, genetic algorithm, only one chromosome. You are evaluating each individual chromosome. One chromosome is giving you the maximum. The others are not giving the maximum. So you can tell only one point is reaching to the optimum. So there may be the chance, see I am not sure, may be the chance that the maximum value which you are getting by GA may stop at local optimum. Okay, but in this PSO there are layer chance. The chance is very rare. It may stop at local optimum. Because in there, once you are getting the local, now see, some chromosomes are in this local and some chromosomes are in this global. But again, when we will evaluate, what will happen? This is a local value, this is a global value. So there is a difference between these. So all these particles here will be attracted towards this. Because that distance, G base minus current position, it will act as a global attractor. It will attract the particles towards that position. So see that. Okay, see the previous step. So now the question is, here you are getting all the particles will converge towards the global. Whereas in the case of GA, only you are getting a single particle or single chromosome is getting towards the global. Let's see this omega. Omega is nothing but your VIK plus 1. Omega into VIK. This is just like a acceleration factor. So, what acceleration? What value you will take? You see, initially when you are starting, suppose I am starting from Delhi to this place. So when initially I am starting, if the road is free, I may start with a larger velocity. When I am approaching towards my destination, I may go with a lower velocity or lower acceleration. And again, when the road is clumsy, you have to deaccelerate. So depending, this omega, sometimes in some problem initially, the omega was kept constant. But later on the people has tried, because once there is a PSO, particle form optimization, a lot of variants, new variants of PSO have been come. You can find a lot of literature on this PSO. And another beautiful thing of this PSO, I'll tell you later on. See, here in this omega, they are changing the omega between a maximum limit to a minimum. Omega max to omega minimum. Okay? So this they are doing by the iteration. So when you are going, when you are starting, you are iteration number 1. You are not getting the global value. But when gradually you are moving towards your global optima, then if you are closing towards global, then you may reduce your velocity. If you are far from your global, you may increase your velocity. That happens mathematically when you are writing your program. When your iteration count is more. Iteration means one complete cycle is present, you are updating velocity, iteration 2, further updation velocity of all particles, iteration 3. So gradually if you go on, suppose you are running in GA 100 generation, here we are telling 100 iteration. In one iteration means, what is one iteration? That means we have updated the velocity of all the 20 particles in all possible directions or in all possible dimensions. If you have 3, x1, x2, x3. If you have n, that is completes one iteration. Then second iteration. So the more will be the iteration number, you are coming closer towards the global. So in that case, you must reduce your value of omega. So that's why omega here dependent on your iteration count. Iteration count is indirectly how closer you are to the global solution space. So this is one. This weight is known as inertia weight. Because this weight changes your own velocity. SI k equal to omega into VIK. So it is the inertia factor which gives you acceleration or deceleration, which can be changed depending on where you are at present. If I am closer to the destination, गाड़ी वाला नहीं है, कुछ नहीं है, I can move freely. But if there is a clumsy in the road, you can put your brake on that. So this is sometimes some people tell it adaptive weight. The weight is adaptive, it is changing. Either it is changing depending on your iteration, either you can change it depending upon your number of counts of evolution of the functions or whatever. These are some comments on the inertia. A large inertia weight facilitates a global surf, while a small inertia weight facilitates a local surf. You see, if an inertia weight is large, you are moving with a high velocity. So you may go towards the global initially. But if you are very close to global and your surge is in and around that, I will clear my point. You are very close to the global solution. In that case, it will get a large omega. Then what will happen? You may fly at that position. Okay, you are very close to the global with a high omega. Your acceleration will be much more. You may go over that. Again, you may come over like. So there is the oscillation type of thing. You may do your transient. You may oscillate about the steady state. Your final value is here. So with a large omega, your solution space. In the solution space, you may fly like this one. So that's why, if you are taking a small omega, then the global, you are searching around the global. That is again local. So people what they have do, either they are changing omega or they are adding some local search method to the PSO. Recently we have added the Nettler-Belt search, the local search, or you can add the Tabu search, you can add the Taguchi search. So these are the local search available. Okay, these can be hybridized with the particle swarm optimization. or you can update your omega. This is the flow chart. I already told you. You start first, then initialize the particles. Okay? In simple optimization, again repeatedly I am telling, initial guess of the solution. In GA, you are taking the initial population, initial member, chromosome 20. Here the particle position. And these 20 or 50 or 100 again depends on your problem. Which problem you are solving. It is not that always 20 or always 100 or always. So that depends. Initialize the particles with random position and velocity. Then for each particle, you evaluate the fitness. Once you evaluate the fitness, but here there is no question the die out of the individual. In case of the GA, while evaluating the fitness, if any fitness value is very low, you are making an optimization, maximization problem. That solution is completely discarded by the regulatory selection or fundamental selection because we are discarding that. But here, we don't have to kill any member of our family. We 20 as a family, as a group, have started the searching operation. So all members have to be carried out. If somebody is inferior, then what will happen? He will be lag behind the global. He will be lag behind the leader. Then the leader will give him the inspiration. Okay, you are this much of distance. Try to update your velocity. Come in behind. So everybody will try to attract him, to pull him towards the global. So no question of that. In general, you will see in the GA also, in genetic algorithm, we are killing the particular chromosome which is not suitable. In real life, can you do that? I have 5 kids. Can I kill one kid or 2 kids because he is not able to compete in this society? So what I am doing? I am finding out whether that particular chromosome or whether that particular child which is not able to cope up in study, he may able to cope up in some other things. So try to immunize that. Try to immunize. Different immunization program. So like that, try to immunize that particular chromosome so that he will be able, he will be fit. So that particular new variety of GA, you see all our biology and social. You can think of something on your own, this will create a new one. So that particular algorithm in GA, instead of killing one inferior solution, you try to immunize that particular solution so that it will be able to compete in the world. That particular version of the GA is immunized GA or immune algorithm, artificial immune algorithm. So there are different algorithms. So completely here, I am keeping the position of the particle, then I am evaluating the fitness, I am keeping the track of your two things. One is the particle based, another is the global based. Again, how you stop, where will you stop? And what is your solution? So in every iteration, iteration means one position of it. In every iteration you are keeping the track of the global based. Now first iteration global based, second iteration global based, third iteration global based, like before. When you will see that there is no change in the global based and all the particle global based and P based are same. So if global based equal to P based, then what happens? Every particle is at the global position. P based means individual based till now. So if there is no change in the P based or there is no change in the G based, that means you have already reached the global solution. You terminate your program there. Either you can give the number of generation or number of iterations, or you can give this criteria if during successive iteration, if G based and P based are not changing by an amount epsilon, the computer will not understand G. You can give 10 to the minus 3 to the minus 5 minus 6, whatever. Then you terminate your criteria, terminate your program there. Clear? So that is regarding the this is a simple comparison with the other evolutionary competition technique. Unlike in genetic algorithm, evolutionary programming and evolutionary strategy, in PSO there is no selection operation. We are not selecting the best one and the best one would compete and survive. That process is not there. So in GA, let's see, there is a selection process, then there is a crossover process. So here there is no selection process. So So one step we have omitted. You will see mathematically computation. Initially you are taking total particle in GA at PSO. But one in between in GA you are taking, you are evaluating, that is also GA and PSO. Then third step in GA, you are evaluating the best one by relative selection. Then you are making crossover. But here directly you are updating the velocity. So velocity updation in PSO is similar to that of crossover in GA. By means of crossover you are getting new side, new solution. Here by updating the velocity of the particle you are getting the new solution. So the one step which is more in GA, that is the selection process, either by relative wheel or tournament or whatever, that particular phase we are not going to carry out. So the time will comparison one evaluation time is generally in PSO it is smaller in comparison to G. Are you clear? Because we are completely eliminating one process, that is the evaluation. Okay, and selection also. The selection of the best one. Then all particles in PSO are kept as members of the population throughout the course of round. There is no question of die-out. There is no question of survival of the fittest. So all are carried out. However, PSO is the only algorithm which does not implement the survival of the fittest. We are not doing like that. No crossover operation. This is simply updating the velocity. In PSO, there is a balance between the global and local source can be adjusted to the inertia weight. So these are the things, and you will see in some papers also they have proved the C1 and C2. We have taken one is the C1 into rand1, which takes into the cognition factor, self P based minus position, and another C2 into rand2, which takes into the global attractive factor. So this C1 and C2 they have a value given by the initial paper of the Kennedy. You will see the first paper of the Kennedy in 1995. The C1 and C2 are they are giving nearly equal at 2.1. C1 equal to C2, that is equal to 2.1, and C1 plus C2 is equal to 4.2 or something. But there are some variations also to it. But there is a mathematical background in PSO. See, you are getting Vi at k plus 1 because there are some mathematics faculties also present. Can you study this or not? You are getting Vi at k plus 1 equal to omega into Vi k plus some constant C1 and 1 is nothing but phi1 into P based minus G based minus what is this equation? If you look into the mathematics, what is this equation? Vi k plus 1 equal to omega Vi k. Is it not a differential equation? It is a differential equation in discrete domain, that is difference equation. X dot equal to ax plus b. The derivative. So Vi, the position at k plus 1 instant, equal to omega Vi k. So you can frame it into a mathematical description. X dot, the derivative, x1 dot, x2 dot, x3 dot, or difference equation. X k plus 1. This is the difference equation. X k plus 1 equal to matrix A x k plus b u k. This you can do a difference equation where you can prove the stability of the method as well as the convergence of the method. Here you will get this. This is the control vector. Uk is the control which will change the position of the particle in the next instant, which will control the velocity of the particle in the next instant. So this controlling factor depends on P based minus SI, G based minus SI, as well as these constants phi1 and phi2. So these two constants phi1 and phi2, which is nothing C1 rand1 and C2 rand2. So the C1 and C2 will prove the mathematical convergence. You will get a particular value of it. Arbitrarily you can take. What is it? C1 and this C2. So there are also some papers you can find the proof of convergence and the proof of stability of the particles for complex. Of course, this is new to all of you. I am not going to the hard, difficult mathematics to prove the convergence or to prove to the stability of this system. But Remember, in GA there is no hard, solid mathematical background. Everything is random. You are choosing crossover randomly, site of crossover randomly, mutation randomly. But here, at least there is a mathematical background behind the movement of each point, which can improve mathematics, which you can advance mathematically. Taking into the convergence, taking into the stability of your system. If you see, if you won't mention stability, all the particles will fly like this and this. They go on flying instead of converging to a particular global solution. So there must be a controlling factor to control the movement of the particles in a controlled fashion, because when water is flowing, either it is a streamlined flow or it is a turbulent flow. If it is a turbulent, you can't get anything. So for streamlined flow, the water flow must be restricted. Okay, you define the boundary, define the restriction, define the velocity. Then you are getting a streamlined flow to reach the goal. So similarly, to have the movement of the particles or movement of the parts in a controlled, streamlined manner to reach to the global optima, there are some controlling factors. That is C1 and C2, which will control the velocity of the. These are the different variants of PSO. Of course, Vidyasagar will know better than me, and different persons are doing different work on the variant of the PSO. As I have already told you, somebody are changing the omega, somebody are changing the other factors, somebody are adding the local search techniques, some are adding also the third dimension gradient information, because here no gradient information. You can find also the gradient information. The present particle x position, xi, the next xi k plus 1, how the gradient is changing. Gradient is slope, the time duration is 1. One step is 1 time. So you can trace the information of the gradient, try to give that information of the gradient. Some people are also implementing your automata theory, the learning factor, the forgetting factor, all these things into this mathematics. When we are flying, okay, my global best is telling come in this direction. Suppose I am telling, you are in my group, I am telling you I am now in this position coming. Are you bound to accept 100% to my advice? It depends upon your own judgment. So you apply your own learning theory. You apply whatever mistake you have done, forget it. So some learning theory, some learning automata, people are adding to this, because you have to develop new algorithm, good algorithm. Ultimately it is to publish a good paper or to give a good algorithm so that group can solve the complicated optimization problem. So the good algorithm can be designed either by a psychologist, either can be a biologist, either he can be a mathematician, either he is a statistician, whatever. Okay, so you try to explore. If you read at least 7, 8 or 10 papers, you can get some idea how to modify the present search algorithm. And all the ideas are based on psychological things or biological things. Nothing great in mathematics. Are you clear? I will forget about this application to power system because nobody understands here. Electrical people also. There are electrical people. The electrical I have asked, nobody was there. Mostly. But I have some other methods also. These are the symbol I have given. The evaluation versus I have compared both the algorithm. Now you can see in GA, this is a maximization problem. This is your fitness value. This is the number of evaluation. Okay, so here I have seen, see this is your GA, this is your PSO. From these two, you can see which algorithm is having a better convergence characteristics. PSO is generally, it is not correct. You can't tell. Those who are at least scholar method will give me a big slap. It will tell me GA is not better. It depends, again I have told you, depends on your algorithm, how you have modified your algorithm, how you have implemented your algorithm, and what is the problem. You can't claim GA is better than PSO or PSO is better than GA. It depends completely how you have developed your algorithm and what is the problem. So particularly for this problem, whatever I have solved here, PSO, although they are giving a nearly same solution, but the convergence of PSO is very fast. Very fast means with less number of evaluation, with less time, you can get your global solution. Because the reason is you have already discarded some of the mathematical operations. You have saved your time. Okay.
नहीं आज in afternoon because
Afternoon, we will make
another 1 hour you have to take it.
yeah, another 2-3.
Like objective.
I have multi-objective and another something I will discuss on information.
So multi-objective will take minimum
हाँ
one.
minimum one.
So we have a long.
ठीक.
If you want another time we will discuss the application and distance. Then maybe multi-objective we can take.
Let there be some. We will discuss this multi-objective in the afternoon. And you can put some question, you can put some doubts.
Included mathematical test. In that Kalyanma their books, which is having nearly so many optimization things we will discuss in their first class. Just I introduced. Now you can find out this solve that which one will fit to your required application and how you can hybridize that. Like the synchronized problem, finding out the feedback, bringing some subscription, bring those subscription, bringing your application. Those type of hybridization. Simple PSO cannot handle your requirement to that extent unless you take your hybridization. There are certain things like some particles going with high speed, going crossing the boundary.
One thing this I already mentioned. When you are solving any, you are developing any new algorithm, this must be tested with the standard benchmark. Two things are there. So firstly you have to take some multimodal function. You see we have taken whatever new algorithm we have developed, we have to test it. It is not to be tested on your problem. And if it works satisfactorily on your problem, you can tell it it's a good algorithm. It can be. Okay. Suppose we are developing a new medicine or a new drug, it must be tested on a wide variety range of patients. मेरा बच्चा भलो अच्छा हो गया तो वो बेस्ट मेडिसिन दैट इज नॉट द थिंग. That's why any algorithm you have to develop should be tested with some standard test function. Here we have taken, see these are the functions, Rosenbrock, Rastriji. There are also websites. You can go to the websites, mathematical test function website. You will find the mathematical description of all these test functions. The beauty of this function are, like see in this function, a number of peaks are there, many peaks are there. So those functions and the number of variables are very there. You see, G, the Kennedy multimodal function generator having 10 peaks, and H function is having here, these are the 100 peaks. And the problem dimension also many. Okay, so here you have to test it. These are the functions, and its values are given. I will give you this slide also. You will take this slide. So Rosenbrock, Rastriji, Griewank, Shuffle function. Okay. Here the number of variables are 500. That means this XR 500 number of variables are there. So all the functions are to be tested. We have tested by PSO. Again, I have told you, in case of GA or PSO, you are running the first generation or you are running the first trial. You are not getting the best solution. Okay. So you are running it for the 100 trials. Every time you are getting a result. Suppose you are maximizing a function, fx. What is the maximum value of function? One value or many value? It is a one value. But every time you are running your GA or PSO, you may not get the same value. The reason is it is a random sort and your process starts from that. Again, it will not take the same time to find the same value. It may take different time. So, how you can prove your algorithm is a robust algorithm or your algorithm is a good algorithm? So, out of 50 runs, 50 trials, you record the maximum value. Okay, if all the maximum value are closer to the global maxima, then statistically you will get the standard deviation of the result is very low. Suppose your maximum value is 500. Now you are getting 500 in one run, 500.5 in another run, 500.2 in another run, 499.5 in another run. So you are getting the result very closely to that 500. So your standard deviation may be 0.5%. But if you are getting one time 500, another time 200, another time 100, another time 499, there the standard deviation is very large. Out of 50 runs, only once you may get 500. So your algorithm is not a good algorithm. Because that 500 you are getting out of 50 trial runs, it may be on 50th run only. Previously it has never come. But if 500 you are getting at least out of 50 runs 25 number of times or 30 number of times